For example 2, we're going to line up our vectors similar to the way we did in example 1. These vectors are at 90-degree angles to each other, so these vectors are actually quite easy to work with to find the resultant. Let's draw our 90-degree angle in here. And I'm just going to realign this drawing so that we can see it as a 90-degree angle. There's our 90-degree angle. Our resultant is going to be somewhere in between those two vectors. If we use the parallelogram law, then I'm going to draw a vector parallel to the 3.5 meter per second vector to complete my triangle. Here's angle theta in between the resultant and the 5.1 meter per second vector. And so we can use our Pythagorean theorem to find the magnitude of the resultant vector. So here we end up with r squared equal to 38.26, if I've done my corrections or my calculations correctly. Taking the square root of that gives us 6.2 meters per second, and that seems like a reasonable answer. And so now to find our angle, let's use the tangent, because again we have opposite over adjacent. So tan of theta should be 3.5 divided by 5.1. Using the inverse function for the tan, we find out that the angle is approximately 34.5 degrees. There should be a decimal in there. Now this is where it gets just a little bit tricky, because we need to picture our original vectors on the Cartesian coordinate system. Here's the 5.1 meter vector, and here's the other vector up here. And what we know is that the resultant vector is 34.5 degrees away from the 5.1 meter per second vector. So when we're trying to talk about the position of the resultant vector, we want to relate it to the southern direction vector. And so knowing that we have 90 degrees in each quadrant, let's take 90 minus 34.5 and calculate, I'm sorry, not 90 minus 34.5. Let's take our 45 degrees that we know exists between the southern vector and the 5.1 vector, and add that to the 34.5 degrees that we found between the resultant vector and the 5.1 vector. And so our resultant vector has an angle with a bearing of south 79.5 degrees west. We started at south, we moved 79.5 degrees to the west before we got to our vector.